So case 3, symbols connected, as a product. Symbols connected as a product. It says when a symbol is connected to one side of the formula as a product, it can be transferred to the other side of the formula by dividing both sides of the formula by it. Alternatively, the symbol can be transferred to the other side of the formula by cross multiplying. So example 7, transpose V equal RW, and we want for R. In other words, we want R to be the subject. So we're given V equal RW. We divide both sides of the formula by W, and we get V over W is equal to RW over W. The W's will cancel, giving me V over W equal R, and I must rewrite. So rewriting the formula, we get R equal V over W. Hence, R is now the subject of the formula. Again, very, very similar to case 3 on equations, where case 3 says equation containing product. So very, very similar. Okay? Questions, guys? A little sample here. Note that it doesn't have to be a single digit. Look at example 8. It says transpose P equal H rho G for G. This little symbol here is not a P. It is rho. Remember to go and look at your Greek alphabet. So it says given P equal H rho G, divide both sides of the formula by H rho because we want G as the subject. So we get P over H rho equals H rho G over H rho, which gives me P over H rho equal G because the H and the rho cancels here. So rewriting the formula, we get G equal P over H rho. Hence, G is now the subject of the formula. So note, when it comes to case 3, it does not have to be a single letter that you divide both sides by. It can be multiple letters. Okay? Case 4, symbols connected as a quotient. When a symbol is connected to one side of the formula as a quotient, it can be transferred to the other side of the formula by multiplying both sides of the formula by it. Alternatively, the subject can be transferred to the other side of the formula by cross multiplying. Example 7, we are to transpose I equal V over R for V. So we want V to be the subject. This is an important formula. One thing about transposition, you use it a lot in science. So for those of you that are thinking of taking science as a major, you may use it a lot more than the others. All right, so let's see. Given I equal V over R, remember, I want V as my answer, so I will multiply both sides of the formula by R. So we get I times R equals V over R times R. The R's will cancel, giving me IR equals V. So rewriting the formula, we get that V equals IR. Hence, V is the subject of the formula. So voltage is equal to current times resistance. Okay? Good. Questions with case 4. Again, case 4, all right? Case 4 is similar to the case 4 of linear equations, where in linear equations we see that case 4 is equation containing quotient or containing division. So there is a similarity there. Also note with example 10 that it does not have to be a single value that you multiply both sides by. Notice here example 10 says transpose f equal v over 2 pi r for v. So we're given that f equal v over 2 pi r. We multiply both sides of the formula by 2 pi r. So we get f times 2 pi r equals v over 2 pi r times 2 pi r. The 2 pi r's will cancel, giving me 2 pi r f is equal to v. Rewriting the formula, we get v equals 2 pi r f, hence v is now the subject of the formula, which means that it does not necessarily have to be a single digit